So, we just took a look at making some complex table views, but there's another issue that we should be quite aware of, and that is saving data. Now, if you think about it, it's a very important thing that your app should be able to do in many cases. Now, where did it go? Is the title of this slide. And that's because if you think about an app that doesn't save data, it's a lot like a pub with no beer. We need to be able to save data within our programs, otherwise a lot of the time they become quite useless. Imagine going, sorry boss, the app doesn't save my work. I'll try again tomorrow. You'd be writing a Pages document today at work and then come back tomorrow and nothing's there and you'd have to start again. It would take you forever to actually get anything done. It would be the equivalent of, the dog took my homework. So in that regard, apps must save data. I'm not sure many people would be happy with the kind of product where it doesn't save what you've done so far, so you can come back to it later. Now, remember back when we covered the MVC architecture in App 1X, that is, the Model View Controller architecture. That architecture comes back into play here. The controller object ensures the correct data is displayed, and it's informed by the model object, which defines how the data is stored. When we persist data in our apps, we'll have a storage layer within our architecture, and the controller object is the one that gives us access to that storage layer. Now we're going to move on to cover something called protocols. Now, think back where we covered the custom string convertible and the equatable protocols. We also have the codable protocol, which is implemented to save data, and that's done in the same sort of way that the custom string convertible and the equatable ones work. An object that conforms to codable can save and load data. To conform to the codable protocol, it requires two methods to be implemented, and I'm sure you can guess what those are. Most built-in types in Swift already conform. So, let's go and take a look at this screenshot here of our book class implementing codable. As with other protocols, we simply had to add this to the definition as well as our custom string convertible. You'll see in the screenshot there are no errors, and this is because string and int, which are the two types I've already used, are already compliant and can be codable. But we still have a little bit more to do before we can say we've finished. In this example, the data will be saved into a plist format. An encoder object is used to encode the data for saving, and a decoder object is used to decode the data from its saved state, so our loading and saving. So let's go and look at those encode and decode in a little bit more detail. So we encode the data with codable. We have another screenshot that we can see in the slide here. Now, the encode method is a throwing method, hence we will use try with a question mark with it. It will now return optional data instead of errors, and printing it gives us the number of bytes in it. Because we are saving it as a plist, we use the property list encoder object to do this. We use the try with the question mark because the encode function is one that is known as a throwing function. Because of this, we need to use the try catch syntax. Hence, we are using the try with a question mark. We create a variable called encoded book, and we attempt to encode our book object, and now we simply print the encoded book out. When we print it, we'll actually print the number of bytes in our encoded book object. So now let's go and have a look at decoding data with codable using decode. Now the decode method is also a throwing method, so we'll also use that try question mark notation with it. It'll return optional data instead of errors, and printing it gives us the instance. So I'm sure you can see here it's the exact opposite, the reverse of the encode. Everything is pretty much either the same or in reverse, if that makes sense. So it's the same sort of type of method that we have, but the steps that we're taking is taking it from the encoded back to the decoded version. Now, the whole point of this decoding and encoding is so we can actually write that data to a file. So far, it still doesn't save the data beyond when the app's running. So if you quit the app and start it again, nothing from the last time you used the app will actually exist. And that still obviously causes those same problems we were talking about earlier for our users. To be able to write data to the file so that our app can reload, it requires us to learn a little bit more about the iOS file system. iOS uses sandboxing to protect it from rogue apps. So let's look into sandboxing in a bit more detail. And we see here a little diagram where we have two different apps trying to communicate with files. App 1 cannot access any of App 2's resources, although in certain cases with user permission, access is permitted. Sandboxing is an excellent way to protect your app and its data from rogue apps and malicious developers. Sometimes the malicious developers don't even know that they are, they simply make mistakes. Sandboxing is there to protect the end user mostly, as well as developers from having the apps destroyed by others. There are certain instances that the operating system will allow an app to interact with other apps' data and so forth, but this is only with the user's explicit permission. You've probably seen that when using apps and they ask if they can access, for instance, your contacts. Now, sandboxing is a very, recent in a way, development on operating systems where it's being implemented. And probably the most notable implementation of sandboxing was on iOS, and it's now spread to other operating systems. Not all operating systems do it in all cases, but it's a very useful thing to have and to be aware of, especially when we're building our iOS apps. But you may see it in other operating systems if you develop for them as well. The Documents folder is the location your app saves to and where it modifies the information. Now that path is like a URL to the folder, and that actual path to the Documents folder changes for security reasons each time you interact with it. Thankfully, we have something called a File Manager class, which gives us access to the Documents folder and takes care of all that intricate changes to the URL. So let's have a look at another screenshot here from Xcode, which talks about the File Manager default URL. What we're doing here is we're creating a File Manager object, and our concern is we want to look at the Documents directory. So we access the .documents directory property, which we use in a call to filemanager.defaults.urls. So Documents directory holds the URL to that folder, and we can actually see to the right there the actual path in the sidebar where it has that generated sort of different string for the Documents directory. We've named this variable Documents directory, and our concern inside the file system is to be able to get to it. So once we do have that URL, which we can store in a variable, we can then use it to proceed to save data to a file. Let's have a look at how we do that on the next slide. So we have another example of code here where we're going to learn how to write to a file. So once we get that documentary, and then we're able to go and grab, by using that directory, an actual URL or reference to the exact file, the plist file, which is sort of a list of a structured data file where we're going to save our data into. So we're then going to say we've got the directory into our documents location. We're going to go and create a file called booklibrary.plist, and we use that with this appending path component and appending path component again structure that we have here in our let archive URL. So inside archive URL, we'll have that complete path to the plist file itself. So then we have to actually encode the book into that property list or plist format before we can put it into the file. So we go back to that property list encoder and use that to encode our book structure into a format which we can save into the file. We then have our try question mark keyword there that we use because of the type of function .encode is. We call .encode to convert it into that serializable format that we can save into a file. We then finally have this new line using again our try question mark keyword format. We take the encoded object, which is encoded book, which is what we called it on that second last line, and then we use .write to actually write it into the file. We tell it where we want to save it, which will be to that archive URL we previously created, and then we just pass it the no file protection options in this case. So it's all well and good to save the data, but then it's not really useful unless we can then read that data at a later time. So retrieving from the file, much like encoding to decoding, writing to reading, it's a very similar sort of structure, and in a way it's both the same and the opposite of writing to a file. So the code here is a little bit more complicated, and we'll be going through it in more details in our screencast. But effectively, at a high level, what's happening is we create a property list decoder object, which then creates and initializes a data object using the contents from the archive URL, which, as we recall, is where we saved our data. We then unpack that data and print the contents. So taking it from that format where it's been stored and encoded, we've decoded it back into the format used within our app. So that's quite a lot to take in. Let's go and think of it again from start to finish. What did we do? We created a way to save data for creating a useful app. We implemented the Codable protocol which allows us to encode and decode data such that we're able to save it to a file. So we then learnt how to use, based on the codable protocol, the encoding and decoding methods, and then how to take that data, write it and read it from a file. Now we're going to go and look in some exercises or some screencasts about how we can do that in an example within Xcode.